Select the product or products formed by the reaction steps shown below. So what we have here is a reaction mechanism. So these curved arrows are always indicating the flow of electrons. And so what we see here in our first arrow, and this is where we start, is we're taking this lone pair of electrons from the oxygen and it's going towards this hydrogen. So that indicates that these electrons that belong to the oxygen are going to be shared with that hydrogen in the product. So we are forming an oxygen-hydrogen bond, okay? And then hydrogen can only form one bond at a time. So if we are going to form this new bond to hydrogen, then we need to break the existing carbon-hydrogen bond. And so we're doing that. And this curved arrow here is telling us that those two electrons that are in that covalent bond are shifting to be shared between these two carbon atoms. So that means that you are forming a double bond. And so we're forming a double bond between these two carbon atoms, which would mean if we don't break a bond here, this bottom carbon would have too many bonds. So when those swing in to form a bond, we break the bond between the carbon and the bromine, and those electrons go to the bromine. Okay, so we've traced all of those. Let me draw in the lone pairs of electrons that were implied to be on the bromine to start with. And we're going to start tracing through these arrows. So start by drawing the cyclohexane portion, okay? And what we'll see here, so this means that this hydroxide is taking this hydrogen from the rings. That's going to be broken off. So we are forming in this step a water molecule. So we have OH, two lone pairs of electrons. We're going to say this last lone pair of electrons is now forming the bond to this hydrogen. So we'll color code it so we can see where those electrons are. So there they are, forming that new bond to hydrogen. So we formed a water molecule there. And then what this blue arrow indicates is that the electrons from this bond are now being shared between those two carbon atoms. So here they are forming a double bond between those two carbon atoms. And then when that happens, the bond between the carbon and the bromine is breaking. So we're going to also have this bromide ion. So it had three lone pairs of electrons, and it's got one extra lone pair, so that's the green ones that are coming from this bond. And so overall, that's going to have a negative charge. Okay, so notice that we started off with a system that we had a neutral molecule and a negatively charged molecule, so an overall charge of -1. And here, our cyclohexene is neutral, our water is neutral, and then we have the bromide with a -1. So we also have an overall charge of -1. Okay, and so this is option B.